we will discuss some basic results of automata composition. In particular, we are going to talk about two things. One is how to take an execution of a composed automaton and then project it to the view of each component automaton. This will be called projection. And then we'll look how to take the execution of each individual component automaton and put them together to get the execution of the composed automata. This will be putting things together, means we paste these executions together to get the execution of the whole automata. So what we said is that an execution or trace of a composition, a composed automaton, can be projected to give us the execution or traces of the component automata. So we will get the view of the component automata of that whole execution. Also, given executions of component automata, we can paste these executions together to form the execution of the composition. The same thing will hold also for traces. So, given the traces of component automata, we can glue them together, paste them together. So let us define the notion of a similarity of execution. In fact, what we want to define is having different executions, but from the point of view of each component automata, they look the same. They cannot distinguish between them, and we call them indistinguishable executions. The projection of a component automata AI in an execution E of a composed automata A. So, will be denoted by this notation. So, here is the execution of the whole, and this is by restricting it to AI, we say this is the view of AI. So what is it? So it's a subsequence of execution E restricted to events or actions and state of the component automata. So we take an execution, we just keep the state and the action that are related to the component automata, and that subsequence will give us this projection of execution A into the component automata AI. We say that two executions are similar with respect to the component automata AI if we restrict the first execution to the view of AI and we restrict the second execution to the view of AI, and we look to these two and we see they are exactly the same. We say that two executions E and F are similar or indistinguishable if E and F are similar with respect to every component automaton AI. We can say the same thing about traces, the same that we said about executions. So the projection of component AI in a trace of E of a composed automata A is denoted by this notation. It is the trace of E restricted to the view of AI. And it is a subsequence of the trace of E restricted to events happening on AI. And two traces are similar with respect to a component automata AI if we restrict the first trace to AI and we restrict the second trace to AI, we see that these two are the same, are equal. And two traces are similar or indistinguishable if the traces are similar with respect to each process or each node. So in summary, given now an execution E that looks like this of a composed automata A. The projection involves deleting actions that do not belong to A and the following states, and then projecting the remaining states on the AI component. So this is as just a summary. And projection of sequence of actions on a component automaton involve deleting actions that do not belong to the actions of the component. So let us look now to an example. The example was our distributed network system consisting of 2 processes and 2 channels. And this was the trace of the composed automata, the network system. And we just look now and see what are the traces projected to process P1. So this event happens at P1. This does not. This happens at P2. This event is a send that happens at P1. This happens at the network, so this is not the channel. This is a send by process P2. This happens at P1. This happens at P1. This is at P2. This happens at P1, and this is at P2. So that gives us the following sequence. This one, followed by this one, followed by this one, and this one. And here we have it like this. So this is the trace projected on process P1. So the first theorem we want to state is, given a global execution, execution of a composed automata, we can project this execution into each component, and we get a legal execution of each component. So execution or traces of a composed automata will project to give us executions or traces of component automata. So just to state it precisely, given a composed automata A, where of course a composed automata requires that the components are compatible, and we defined compatible earlier. So we say that if E is an execution of A, then also E restricted to a component AI is an execution of that component, and that holds for all components. The same thing holds for traces. So if beta is a trace of A, then beta restricted to a component will be also a trace of that component, and that holds for all components. Next, we will do the converse, which is, if we know the executions of the components, we can glue them together to get an execution of the composition. So execution of component automata can be pasted together to form executions of the composition. Suppose that EI is an execution of the component AI, and beta is a sequence of external actions of the composed automata. So if beta satisfies certain properties that we just mentioned now, we can put together the executions of the component automata to have an execution of the composed automaton, which is the condition. If we take beta and restrict it to each component, we find that it is a trace of that component, and that happens for all components. Then we can get an execution E of A such that beta is a trace of E, and that execution can be restricted to each component to get the execution of the component. We can state the same result also for traces. And it looks like this. The traces of component automata can be glued or pasted together to form the trace of the composition, and that is as follows. If beta is a sequence of external actions of A, and if we restrict beta to each component, we get a trace of the component for all the components, then beta is also a trace of A.